are. I think you'll tell me how to.
Computer vision.
Yeah, I think you'll tell me how to make that work, though.
That'll be the project nice here. I'm not talking about any of the cool stuff. So backstory here is basically that I work for a library that, like everybody else in the library archive space there, has an absurd amount of scanned imagery. There, for anyone who hasn't seen this, it's actually kind of impressive. Scanning has become an industrial operation. There are machines that you put books in, they will gently pull each page over, scan both sides, do this at a rate that you can basically follow watching. So we're swimming in content, and of course, staffing has been going like that for dealing with it. So we have an incentive to get a little creative in some of the things we can do with that. And that leads me to really the message that I hope people get out of this, which is that as developers, working with numbers or text is old hat. Nobody thinks twice about running crazy text analysis things. You may realize that there's this huge field in computer science of analyzing text and doing this, and 99.999% of the people just download a copy of Solr or Elasticsearch, toss a bunch of documents in, and assume somebody's smarter with more spare time to take care of those hard problems. So we're not there with images, but I think there's a lot more than we give it credit for. And the idea that this is sort of, you're either scaling, cropping, rotating, or it's a hard problem, is something that we choose to believe more than it is actually true there. So I kind of wanted to show a couple of fairly simple things that I did, and this leads me to the other part of that message, which is the takeaway message should not be, wow, that Chris guy is really smart. It should be, if he can do this, I can probably do something similar, because he spent an afternoon working on this and got something that actually solved a real problem. And it might not be quite as easy as whacking a regular expression together, but it's not as much harder as you might think. This is after turning off auto-join. So, Wi-Fi, that's still a hard problem.
Oh.
So, backstory for this one here. The World Digital Library is the project that I work on. It's a collaboration between the Library of Congress, UNESCO, a couple hundred other organizations around the world. The way it's been branded in the past is sort of the cultural greatest hits collection. The idea being that rather than just going for massive quantity, you get high quality. So the metadata has actually been created and corrected by humans. It's translated into 7 languages. All this fun stuff. And there's a lot of neat things. So if you want to compare multiple copies of the Gutenberg Bible or something, you can go to wdl.org and you can go check out the details of every character on every page, which is nice. There's one little problem, though, which we ran into, where I'm going to actually do the thing people never do, which is demo the old version of your website. And the reason for that is that it launched in 2009. And so that meant that, we have thumbnails, which at the time were a reasonable percentage of the screen on that 800 by 600 monitor that was probably the best you could assume that the average person globally had. These nice images, but there's a maximum size. And that maximum size is now well under the icon sizes recommended by iOS, Windows 7, Internet Explorer's web tile feature. This is basically the highest resolution that we have thumbnail in the past was now, tiny on a retina display. It's a detail on people's icons that they're using. And that leads me to the other part of this problem. We have the original images. We can go back and process them, right? Oh, except that everything is done by hand to get the maximum image quality. So those images have been cropped, rotated, they've been contrast adjusted or color balanced there. And that means that we can't just do something like say, oh, let's just run this through ImageMagick. There's even a few approaches here. So I'm going to mention OpenCV's template matching because although I didn't use this is actually a useful technique and it's very simple. It is you take 2 images and you put one over the other and you compare some metric for how similar the pixels between them are. And then you move your target image 1 pixel to the right and you try the same thing again. You repeat this until you've covered the entire image. And if you get anything that's over a certain threshold, you say, well, that's probably where that came from. It's simple, it's even GPU accelerated these days, and it doesn't work at all if you have rotation, which we had tons of. So keep that in mind should your needs not need to deal with that. And this was around the point where I was realizing that we had thousands of these, and our content team would resign in disgust if I asked them to go through and recrop all those images in addition to doing their regular jobs. So that was where I got to learn a whole bunch of terminology, which I did not previously know, and find out just how many of the documentation pages, FAQs, example code had either rotted over the years, were in antique C or poorly written things. They were using the OpenCV 1 interface instead of OpenCV 2. And so after a fair amount of time, I had something working. But more importantly, I had something that I understood, and it's now out on GitHub. So should anyone else have this need, it might even be useful just to understand how this all works. So I'm going to give a little example here. Up in the corner here, you're seeing the original thumbnail image, and you're seeing something of the same size that was reconstructed by locating that original image in the master image, and then constructing a crop box, cropping that out, and scaling it so that the coordinates match. Now, this is using something called SURF, which is one of the algorithms available on OpenCV. All it does is you give it an image, and it will identify features for you. So the features are not necessarily anything that you would consider meaningful. I mean, if you look at this image here, you'll see these dots in seemingly random locations where maybe there's two lines intersect, or there's a change in color or something. But that tells you algorithmically that something was interesting about this. And then you can use tools that will go in, and another library function will go and rank the features that match between the two images. So then you can just construct something like, I need a box of such and such size, and it contains all of these features, or more than a certain percentage of them. And you can do that, and you end up with something like this, which is basically very similar. And the nice part here is that this works even in cases where the image has been altered a bit. It's a little hard to see on the color on the, this map is not particularly easy to read even in the original there. It's rather old. But basically, this image up here, both of these have been rotated. So if you look right here, you can see that there's a body of water, which is actually parallel to the horizontal axis of the frame here. So we detected that 90-degree rotation. Also, though, if you notice, this image is much sharper than this other image down here because it's been contrast adjusted. A lot of the image matching algorithms, the simpler ones, break for things like that because they're trying to do things like compute pixel differences and contrast adjustment, sharpening.
You can turn off Wi-Fi.
Yeah, I had turned off Ask to Join, and so, anyway, this is also one of the things which I left in here. So if you are looking to use code like this, there's this handy display thing so that you can just go in and manually review the matches, compare this, confirm to yourself that the algorithm is actually doing something that makes sense to you, rather than seeing a bunch of numbers printed out in the console and having to open it up in an image editor.
So this algorithm doesn't use pixels to create the features? Like, how are the features?
It does use pixels, but it's not just simple pixel. It's not just like doing something like calculating the distance between pixels in the same position or something. It picks points in the image, and they have actually there's like I think half a dozen at this point different algorithms that are in OpenCV. Some of them work better for certain classes of problem. But the idea is basically they tend to be, so they're rotation invariant, so they will give you the same results even if it's been arbitrarily rotated. This one's showing a 90-degree rotation, but we had a fair number where it's like 5 degrees or something, and that works. And then most of them they tend to be somewhat color robust, so if you have complete changes in color, that would fail. But if you have something where it's like a little more contrasty, or this one's yellower than that one, they tend to handle that pretty well. So like one of the common applications you'll see for this is if people have like an app that will take 2 photographs and match there. One of the goals for a lot of these algorithms is being able to recognize that, say, the picture of your desk is the same regardless of whether you had the window open when you took 2 pictures, or those kind of things. So this is an area where I will cheerfully admit that I'm totally out of my depth on exactly how that works, but the nice thing is this is covered in the academic literature, and there's a lot of discussion. Like if you were doing this with video images or things like that, there's a ton of research available, which is nice. Other people have written that code and submitted it to OpenCV. The other part which I should mention is, although I'm talking about this as like, oh, this is some academic code, OpenCV is really battle tested. Like a fair percentage of the iPhone apps that do like arbitrary detection of barcodes or products from the camera are using OpenCV with the Objective-C bindings. And a lot of people have done some really smart things. So if you've ever wanted to see Python using 4 cores of your CPU and keeping the GPU nailed on your laptop without you having to write a line of code to do that, this is the way to get in there, because they have put a lot of work into parallelization. It actually ran considerably faster on my MacBook Air than it did on the servers that I used on EC2 to do the real job, because those servers don't come with GPUs, and the GPU on your laptop is actually pretty decent for this sort of thing. So I'm going to touch on this later, but there's actually a bunch of other interesting things you can do with feature detection. I'm doing basically like the tighter shoes level of this. Other people are running marathons and doing some really cool stuff. And so last slide, I have some cool things. Anyway, when we got done with this, obviously we had a bunch of these reconstructed thumbnail images, and we needed a way to compare them, because this is an algorithm doing something blindly, and we have no idea whether the results make any sense at all. So we have a few number of items which, this is a great example of something. This is hard to match. Why? There's almost no contrast in the original image. If I showed you a couple of slides out of this collection, as a human being, it takes you a second looking at this, processing where the little slightly less yellow bits are there. And so this one matched, I think it was like 3 or 4 points. I mean, it's only a small number, and that meant that we couldn't reconstruct the crop box with any reasonable degree of accuracy without pre-processing the image a little bit, which, given that we had a handful of these, we actually had a few cases where the content team looked at this and said, this would be better if we improved the original master image for display purposes, because as a human looking at it on the website, it's not very useful. So we fleshed out a bunch of those. How did we do that? Well, one of the problems we had, we want an automated way to do this, so the whole goal here is to avoid huge repetitive processes. We don't want to do something that's OpenCV driven, because we don't want to ask the tool to audit itself, and we don't want to do something that's just the really simple, do like the image magic comparison or something where it's going to fail even if the pixels are slightly different in color there, because a lot of what we're doing is close enough. Incidentally, one of the interesting things we found is a lot of the corrections that have been done earlier, like sharpening thumbnails, those turn out not to be necessary if you have images of higher resolution. So we had a fair number of them where the sharpened ones looked fine at the original 255 pixel height, but when you made them that much larger, they started to look artificially sharp there. And that was kind of interesting and also a very pleasant discovery, because it meant we didn't have to replicate any of those adjustments. We would just go with the answer that what we were going to do would be true to the original image that you would see if you clicked on it and viewed the whole thing. So instead, we used a library called phash, which I wanted to call, I have some more mentions of this in the last slide, because this is actually kind of an interesting thing. It's perceptual hash. The idea is that it's trying to build a hash of an image, audio file, or video, and those hashes are supposed to be fairly robust. So some people are using this for things like Google's Content ID on YouTube, where they want to make sure that you can't defeat their detection algorithm by doing something like cropping videos slightly differently there. Some people are using this for things where you toss a huge pile of photographs in some assemble directory, you want to cluster them based on how similar they are, because you've been working at this for 10 or 15 years. You have a lot of duplicates that have crept in over the time. You want to know how many unique things you have. And at the time, there were no bindings on PyPy that installed cleanly, and in the grand tradition of things, I created another one. This one, though, is nice. It uses C types, so it works in regular C Python. It works in PyPy. I think I even tried it under Jython, but that's somewhat masochistic. Startup times are brutal, but basically, what I used this for was just the simple thing that you see right here, which is you install the module, and then it has a compare images script, and you can give it 2 images, and it spits out a floating point value that you can use there. So if you have a bunch of these one-off comparisons, you can just automate that whole process. And that led to some interesting discoveries. Like we have one of the sketches that was for the Vietnam Memorial, and the image is very interesting. It's this like soft, I'm assuming that's a pastel or chalk, and so OpenCV just completely matched the wrong part of that image there. So that was an easy one. That showed up as like a 0.2 similarity in phash. This one was actually kind of interesting. The National Library of Uganda had sent us some books, and this was the original image that we had, and it failed with a low match rate because somebody had photoshopped out the stamp that a previous owner had put in. So the image was in there. If you opened the book in the viewer, you would see it, but on the detail page, you wouldn't. And we took those kind of things. We actually went in and decided that this was a good opportunity to bring things closer to what you would actually get looking at the physical item there. So it actually helped us learn more about our collection. And we'd had a few garden variety errors where the image had switched over the years as items were being divided into batches, so some of them were completely wrong. And those all turned up in the first few minutes of running this. Then we had a few things that we had to review, the closer matches, but it saved an enormous amount of time, because we basically were able to put the results into a web page like this, where you could just toggle a key, and you would see this was the small size, and you could hit B to show the larger size there, and so you could compare the detail, compare the matches, and this one, you can see I just took a screenshot from the thing with an entire run of 10,000 items. But what was a lot more useful is we took phash values for everything. You could just say, show me the top, or the lowest 100 values there, so you could take your images which failed the most spectacularly, and then you flushed out, oh, this one actually, this was corrupt, but it was one of those delightful corruption things where libtiff just decodes it partially black rather than giving any sort of error messages, and those were very easily flagged. Yeah, I have more image processing stories than you want to hear, and they're all lead to rage about people who develop libraries. So, anyway, that's this demo here. It's pretty simple, but the code should hopefully be fairly legible here, and it actually has functioning command line help explaining all the options here. In particular, depending on the images, there are things that you would want to tweak to balance accuracy and runtime. This is one of those interesting things where the more pixels you toss at it, not only are the results slower, but they're frequently worse. And that's because the larger the resolution of the original image, the more opportunities you have for the feature detection algorithms to match minor differences that are so small that a human would never notice them, but they stand out dramatically whatever function you're using. And if you trim everything down to a certain size, I think we used it was 1,000 by 1,000 for a lot of them, you would get better results, but not consistently. So you would run it per batch, then take all the outliers and run them with a different value, and do that once or twice, and you would basically process all of the images without having to hand correct anything. Before anyone asks, yes, we did save the coordinates for all these, so we never have to do this again. One of the things this will do is give you a nice JSON file that lists the coordinates and rotation angles of everything it found. So I'm also going to show off another old project here. see, Eddie needs to get better at getting me in to present on these things sooner, because this one goes
Sure.
all the way back to 2013.
I suck.
No, I should volunteer, but anyway, this was a project here that I tossed together. This is speculative. We have not used this for anything real, but it's a really interesting experiment, which was basically, we have all these scanned things. And the problem is that's not helpful if you're trying to get somebody to find something and you say, here, 1,500 pages of an old newspaper, good luck. And one of the things we've done is, we've done bulk OCR, and I actually have another blog post about how I did this and some of the, there's a Django Haystack extension and some fun things like that. But one of the things I was trying with is the other angle, which is, could you give somebody a visual atlas of an item where you could say, here's all the images that we detected from here, there. And that's kind of an interesting opportunity to show something like a newspaper has a lot of stuff that you might not care about, but things like maps or photographs are frequently the thing people come to a site like Chronicling America to look at. So played around with this. This is also nice. It's using the OpenCV GUI toolkit, so you can interactively tweak all of the parameters that it's using for the edge detection algorithm to see how they work for a different class of images here. Here's the highly scientific screenshot of the Mac window clustering feature here, showing just a wide range of different things. These are like some old medieval manuscripts. You can see that the combination of the, I think this was actually vellum, but basically the background is patchy enough and the text is ornate enough that it matched basically the entire page, which is not what we want. But then, you know, when you get into slightly more modern era, anything after, say, 1800 or so, you start getting actually surprisingly good results for something like this. And I actually have on that blog post, which is linked off of the image mining project there, I actually ran a bunch of books through this and generated photo galleries. And I included this one because it's, you know, we matched all sorts of things that are not text, including the barcode that's the cataloging number. So if anyone wants that, we'll hit them up front with the barcode and tell them this is why they should read that item. So do we have any questions before I get into the traditional end of slide brain dump with all of the exercise for the student? So, okay. So basically, first point here, if you look at this code, I hope what I've written is reasonably easy to follow, but one of the things you'll quickly run into if you deal with something like OpenCV or Scikit or what's a CVV is a lot of these are written by and for computer scientists. And that's good because it means that a lot of people have spent, you know, a PhD level time working on whole classes of algorithms that make these things possible. But it's bad in that there's a learning curve that approximates a brick wall. And so you're going to be spending time on Wikipedia and then more time looking up the terms that the first Wikipedia page that was written by a grad student somewhere wrote. And, you know, it's an educational process, but I definitely think that we are sort of, for the older people in the audience, anybody who remembers late 90s, early 2000s when people mentioned full text search, this was the exotic beast that companies from places like Boston or San Francisco would trot out a large number of computer scientists working for them and say, we solved this. That's kind of where this feels, where you can do a lot of really cool stuff, but we are still waiting for like the, you know, Elasticsearch repackaging of the same toolkit with a really slick API and awesome documentation and, you know, examples. I would like it if some of this could happen in Python. So that was this was my very modest contribution to that, where I basically contributed some command line interface stuff and some reasonably sane defaults. But you know, anybody who's interested in looking at lots of images and wants to really productize this, you know, I think there's a lot of work for that right now. So here's a couple of cool things here. So feature detection, we were talking about earlier. one of the really cool things here, which I would show if we didn't have to deal with the Xfinity login gods, which is
Oh,
this.
so we do have the Wi-Fi over there. I can set that up.
Well, if we want to pull that up, I guess we can.
Yeah. It's not Xfinity. It's
Yeah.
ABCS that thing.
Yeah, in lowercase.
Let me go close a bunch of other stuff here. And here we are. Wait. Yeah. I think I can. Excellent.
Apparently it doesn't need your email.
You can just type in the password.
Oh, well,
President Way, type out.
I volunteer to test whether or not this
No, it's the
is.
numeric code.
Yeah, that's the 880.
Oh, yeah. Yeah.
Apparently the first one's optional, the second one.
Yeah, we're
Oh. So, anyway, let's go ahead and open this one up.
There may be 600 tabs here to open. Yeah, try to do it in Safari. Sorry.
That's interesting. Okay. Right. And this is in the wiki here. So basically, this is a thumbnail service here, and this is, I believe it's actually written in Python. I meant to check that before looking at this. Yeah, setup.py. So, obviously, this is high-quality software that we should all be using. Anyway, it's a thumbnail server. One of the things that they added to this is a really common ability, which is sometimes people know exactly what they want for a thumbnail. They just want the exact same image they have. Everything's consistent aspect ratio. That's great. Then there's the rest of us who get images of varying sizes, and you need something like a nice, consistently aligned set of icons in a row on a table or in search results. And so you want to crop the input images, but you don't know where because you haven't had a human tell you this. So the first pass that they do for this is face detection. OpenCV has a really robust face detection library there. There's actually two uses of it. The simple one is just this mode, where you could basically just take a picture and drop boxes around things detected as faces. And that's fast enough that you can do it in real time with video. That used to be like a demonstration that people did, and now it's just a parlor trick with OpenCV because so many people wanted that to work. So that's a really simple first pass, is you look for all the faces. And if you find more than one or two, crop around them, because people like seeing other people. And they definitely don't like seeing their elbows. They want to see them smiling or grimacing or something. So they use that as an option to automatically generate this crop box here, and they basically try to weight things. So if you have a whole bunch of faces, they try to get the maximum number that would fit in whatever you're doing there, whatever size image you want out. Then they have this other mode, which uses the feature detection algorithms here, and the idea is basically you process the whole image, and if you have a particularly high density of features somewhere, that's probably a point which is going to seem interesting to a human as well as to the algorithm. And so if you don't have a better way, just doing your crop centered around that is probably better than anything else you can do. And there's the usual slop, making sure you don't go over the edges, all that fun stuff. But it's a really neat idea, and I feel that this is the kind of thing that right now we hear about, oh, that sounds like a bit of work, and like 10 years from now we're just going to be disappointed if you upload an image to a web page and it doesn't crop things intelligently or it's too small to see the detail in there. So that's a neat project that is worth a look if you need to serve images that you don't have marked up nicely for you. Okay, here's another site which I would heartily recommend going to if this is at all interesting, which is basically how to build an image search engine. Ever wonder how Google Images works, or how things like TinEye let you find where people have been copying and pasting images from for years? There's a whole Python course on doing this, complete with annoying ads, but basically you can do this. One of the uses with the feature detection thing is you can actually build a database of features, and you can start saying, okay, I have something and I think it came from one of these 100 images in this directory. Let me try to find the most similar ones. You can do various things with the p-hash types of approaches, where you're trying to just cluster them on a much faster but probably less reliable algorithm there, which might not give you as high quality results, but it scales up to millions or larger image sets. So again, if you need to do this, I would recommend looking at either of those projects there. And then the last one, I'm not really related to anything you should be doing in Python directly, but it's just a very cool project here. This guy in Australia did, which was the real faces of white Australia. So basically, in the early 20th century, Australia sort of rebranded itself as, we are a white country of white people run by white people, and it's always been that way. And as historians and social scientists do, there were people who immediately argued that that was bunk. How do you prove this? Well, one of the ways you do this is you run a face detection algorithm over a ton of historical documents, and you pull out all of the faces that show up, and you start classifying them so that you can say, if you look at any given scene that's taken on a city street, here are all these people who undercut the official narrative. Here's the background, and yes, the mayor in this picture was Mr. Waspy, but the people next to him were not. And that's a really interesting thing, because there's a lot of these questions that you theoretically could answer if you could just get like an army of student interns or something and say, here's 1,000 images, we know what you're doing all summer. And then you can actually do them realistically on your own without needing to convince somebody to let you get that 1,000 students and then have them look at photographs in 1914 newspapers there. And there's actually, since I originally did like the figure extraction one, I had a really fascinating email exchange with a woman who works at UCLA was using this to extract images from a set of published, it was actually kind of morbid. It was, she's working on a history of lobotomy, and they had all these papers that were published by one of the doctors who had basically been like the foremost proponent, the one going around saying we should do this to all of our troublesome mental patients and that. And nobody had ever really looked at the full collection analytically before, because it was too hard to extract all these things. And so she was taking that and running them through and then doing something useful with the results. And so that's kind of where I was trying to go with that image mining thing. Is sometimes you can actually get some really interesting places if you change this from a, how would we ever get enough time to review all of this by hand? So
this algorithm is just picking the faces out,
yeah.
Right? It's not actually saying this person is an Asian.
No. Although you could do some of the image classification things with enough training and tuning, you might be able to get something like that. The other thing, the face detection thing, the more advanced models that they do, you can actually build up a library. If you've ever used like Apple and I think Adobe and Google have been doing this, where they will try to auto tag faces that show up in multiple photos there, those are using the same family of algorithms. It's just basically saying like you develop a signature for each face and you can do similarity matching. So depending on how much additional processing you want to do, you could try to track individual people or try to classify things like, you could probably even do things like, are they wearing glasses? Do they have a hat? There's a lot of stuff that you can put through a classification algorithm. And I've seen other people do really cool demos, and one of these years I want to actually carve out enough time to try doing some of this. The one catch for a lot of the image classification stuff is it tends to require completely absurd amounts of training data. I remember there was, who was it? One of the Google researchers had that great paper like 5 or 6 years ago. It was was it something, the irrepressibility of data, but basically he was pointing out that there were whole classes of algorithms that people had experimented with and then largely given up on, and they were now coming back into vogue at places like Google because it turned out that they would give you good results if your training set was in the tens or hundreds of millions of inputs there, and they just, you needed absurdly large data sets to get them going. So like the Google image people, every year they're publishing these papers talking about things like auto-identifying images, and they're doing segmentation on a video where they'll tell you that this is a dog and there's grass and there's a building back here and there's clouds in the sky, and that's really cool, but realistically that part is still requiring a Google level investment to do the training and throwing, you know, some completely absurd amount of computation at it. So I think for most of us we're at the computer assisted stage where you could make tools that would make it easier for someone to perhaps review or cluster things that are very similar so they could tag a whole bunch of things at once, but that would be useful input to a classification system. There's not a real shortcut around that.
Borrow some of Google's data.
Yeah, well, and then there are people who do things like this. I've seen people getting subtitles for videos by uploading them to YouTube and then having humans correct that because that's cheaper than paying humans to type it in from the beginning. And it's just, you know, go back 10 years, that would seem like you were just pulling somebody's leg. So. Let's see. While we were talking, I remembered one other cool project.
Is that Sean Redman?
I'm not sure who's worked on this. I was hoping they'd have a nice blog post. Yeah, so New York Public Library has a ton of historic maps. One of the things they have a lot of are these building diagrams that were done actually by insurance companies. If you're getting fire insurance, they want a really good plan so they can charge you based on things like how many water taps you have and what the fire exits are and all this fun stuff. And so there's actually surprisingly good detailed internal architecture record of large parts of New York City. And they have a ton of those, and they're all scanned, which is not particularly easy to work with for lots of questions that people are doing. And so the people at NYPL were using some of the image processing algorithms in OpenCV to try to detect areas, find lines, and because the original maps have been fairly consistently color-coded, even try to determine what different types of areas were present. So you could start saying like, well, hey, this building that was built in 1924, you know, how much of it was bedrooms, how much of it was common space, how much of it was, you know, how many staircases, what did they have? And that's another neat example of somebody with a problem that you can't solve with simple image processing, but it turns out that one or two developers with a not small but not enormous amount of time can actually start getting somewhere on this. So, anyway, that concludes the demoing cooler stuff that other people have done.
So you made the plea to say that we need some nicer APIs for some of these libraries.
Yeah.
And that you started from scratch.
Yes.
And you came up with something. What was the timeline?
Well, basically the figure extraction and the thumbnail matching both probably were on the order of like 3 or 4 hours to get something working well enough that most of the remaining work is like the, you know, boring software engineering parts, or, you know, checking to make sure you got the math right for rotations or stuff like that. The backstory for that is that my wife is a teacher, which means that she goes into the classroom a lot on the weekends. And one of the times I decided that as she was going to be working on the weekend, I should actually do something useful, and I've been looking for an excuse to try OpenCV. And so I, you know, locked myself in a room with the laptop, and you know, I had that, the figure extraction processing our cleaner scanned books fairly quickly. I mean, that was probably like 4 hours later. And then I probably spent intermittently, probably like another, you know, 10 or 20 hours over the next couple of weeks, adding all the tuning options and tweaks to handle some of the really noisy scans or the very odd color ones there. The thumbnail matching was also, wasn't that much. I did have a few detours that were things like, should anyone want to run a current version of OpenCV on Ubuntu 10.04 still, I have a PPA available, because that did not used to be available, and it was really annoying. I didn't want to build it by hand and install it on a bunch of servers there. But yeah, I probably spent as much time like tossing it into a Celery task and queuing jobs on EC2 in there. That part was fairly simple.
Have you tried running any of the GPU intensive things on the AWS GPU instances, or does it also need regular old 86-based things?
Those will actually run really well on the GPU instances. Being a cheapskate, I was using this on servers that we already had pegged, which did not have GPUs, but the one test I did, it looked pretty nice.
Okay.
So if you were doing, I was in that weird space. I had tens of thousands of input images, but not hundreds or millions. The more you had, the more it would, this would be like the classic buy a ton of spot instances on EC2, run as much through, and then just turn them all off when you're done. If you really want to, I would definitely go for, get the large ones with a lot of GPU capacity. As far as I could tell, the OpenCV stuff scales basically linearly for the feature detection and the comparison of the common points between those. That seems to be very mature code. That was quite nice to see.
Cool. Thanks.
Are there Python 2, Python 3 issues people should know about going into this stuff?
I don't know. This is all done under Python 2. I thought the hang-up would really be NumPy, and I thought NumPy has been Python 3 for a while.
Yeah.
So I would suspect by now, let's see whether I have any idea what I'm talking about. OpenCV. Well, as of August, it was in alpha.
August of which year?
Oh, beta.
Release candidate 1. There you go.
Is
So-
that for OpenCV 2.0 or OpenCV for Python 3?
So it looks like OpenCV 3, the release notes on that earlier one were saying, there we go. Greatly extended Python bindings, including Python 3 support, and several OpenCV Python tutorials. That's great, because there weren't as many of those in the past, and one of the problems, OpenCV 1 for Python was your classic, that was a C library that somebody had put some effort into, but the API felt alien on Python because it's C conventions. OpenCV 2 is actually really nice to work with because it's just using NumPy for everything. So if you get something, hey, what is this? Oh, it's a NumPy array. I can do anything that I can do with a NumPy array here. I want to get a thumbnail out of this image that I just loaded. Can you calculate slice coordinates in Python? There is nothing else to think about. You already know this. Over and over again, the OpenCV 2 stuff was the way to go, except if you were trying to go through and find other people's code. The OpenCV community, there's a fair number of people on Stack Exchange, and then they have their own community answer site like that. And there's actually a lot of high-level discussion going on. There's some really smart people who are volunteering a lot of time on image processing things. So one of the more common ones seems to be people who are doing things where they take a picture or video with a phone and they want to find text and then OCR it there. And there's actually now like some really good tutorials on things. So there's certain areas that are very mature and you can just go in and find a tutorial that does exactly what you need. And then there are other areas where you get the feeling that you're the first person who's gone walking down that deserted path in a particular long period of time. So your first bit of thing will be updating things like deprecated library functions and constants that moved at some point there. So anything that's people getting more attention on getting into this easier will move a lot of initial startup hassle. Let's see, actually, anything else cool going on? Here we go, yeah, that first bullet point here. Where I was saying that was really common, it's now becoming a standard feature, text detection. So, yeah, I suspect that you're going to see a lot of things getting more attention over time, just given how many people are using this. Particularly now that everybody's walking around with a pretty processing power equipped sensor. There's actually a lot of neat things that you see people discussing that sound cooler than whatever you're working on. I wish I could be your company. So, anyway, look for the release coming sometime soon. So, any other questions, or we?
Cool.
I think I did follow the tradition of packing as much material into the last slide as possible.
You did. Best thing, did you see car detection up there?
Oh yeah.
That's amazing.
You
I have no use for that whatsoever, but car detection sounds awesome.
There was somebody who was using that to build their own speed cameras so they could prove to the city they lived in that the road in front of their house was unsafe.
Oh my god.
Yeah, no, I mean, I saw that. It was just like, that's kind of a cool project, and this is how we're going to enter the surveillance state. It's not going to be all the mass stuff you want to worry about. It's going to be a $99 box on Amazon that you can buy to keep tabs on your neighbors.
And like, why would you build it with 2 pressure sensors a meter apart? That would just be.
So does anyone have any announcements?